This is another video related to Chapter 1, Section 5 in your Chemistry 103 textbook, and this is on converting between units. So we're often needing to convert units to properly perform calculations. You might measure something in grams, but then a calculation requires it to be in kilograms. You actually do this kind of thing all the time, you just don't know it. So, a question like how many hours are in 3 days, how many dimes are in $2.50, these are actually conversions. So I'm going to walk you through a strategy for doing this type of conversion, and we'll use an example converting 3 days to hours. And you can probably just tell me what that is off the top of your head, but attaching that process to this strategy will help you learn the strategy. So the first step is to identify the starting unit, days. Then we're going to write the measurement, the 3 days, as a fraction just by putting it over 1. If you happen to have a measurement that was like a density with 2 units in it, like grams over milliliters, you would put the milliliters on the bottom. Next, we're going to identify the ending unit, and so that's hours. And then here's the key part, is step 4, identifying a conversion factor. A conversion factor is simply an equality, an expression that states how two things are equivalent to each other. And so in the case of days and hours, 1 day is equal to 24 hours. So that's probably the most important step that you've done so far. Step 5 is that we're going to take that conversion factor, that equality, and write it as a fraction so that the unit we're starting with and trying to get rid of is opposite where it is in the starting point. So since we're trying to get rid of days, we want 1 day on the bottom of the conversion factor. And here's why it works, is because since this is based on an equality, the fact that 24 hours is equal to 1 day, having it in fraction form here is is equivalent to a 1, to multiplying by a 1, because anything divided by itself is numerically equal to 1. And so since 24 hours and 1 day are equivalent, setting it up as a fraction is not changing the value of this 3 days, it's just giving us the way to express it differently. So step 6 is that we're gonna do the multiplication. We're gonna take our starting fraction and multiply it by our conversion factor, and there should be units that cancel out. In this case, days are canceling out, and the final product here will be, after you've done that math, so 3 times 24 gives us 72, and it should have the units that are left in the calculation, so that would be hours. So let's try one with metric prefixes. This is what we're going to do the most. So what if I asked you to convert 805 centimeters to meters? You might be able to do this in your head as well, but let's go through it in the systematic way. So I'm going to rewrite my problem. I'm trying to get 805 centimeters to meters. And I'm going to examine my conversion factor. So I need to figure out what that relationship is between centimeters and meters. How do I fill in numbers here that give me an equality? I'm going to think back to my table of metric prefixes that was covered in the last video. Centi, that little c, means 1/100th, or 10 to the minus 2. So I'm going to rewrite that as 1 centimeter equals 10 to the minus 2 meters. And the key here is that the centi should be opposite the 10 to the minus 2, and that makes that expression equal. You may want to write it as 100 centimeters equals 1 meter. That would work as well. That's mathematically the same. My approach, though, is to always have the meaning of that little prefix, that little c, be opposite it. It's kind of the foolproof way to go. So I'm going to take my starting value, 805 centimeters, and I next start to draw in my conversion factor, but I always write in the units before I write in the numbers. And the reason why is to set it up in that proper way such that the centimeters cancel out. I want to have centimeters on the bottom. And then I look back at my conversion factor right here, and I fill in the numbers in the conversion factor from that equality. So that equality says that 1 centimeter is equal to 10 to the minus 2 meters. So as long as I have them on opposite each other, at top and bottom or bottom and top, I have a fraction that's equivalent to 1 and is just moving decimal points. It's not changing the measurement. Centimeters cancel out, and I end up with 805 times 10 to the minus 2. That exponential will move the decimal point 2 places to the left, and so I end up with 8.05 meters. Let's do a slightly harder one. 9.6 milliliters to nanoliters. This is a little harder because I'm not going back to the base unit. So my approach for this is to use two conversion factors. You could ask yourself how many nanoliters are in a milliliter. There's definitely ways of making one conversion factor to capture that equality. But my approach is to write two conversion factors. First, what's the relationship between milliliters and liters? And second, what's the relationship between nanoliters and liters? So I'm comparing both prefix units to the base unit liter. I'm going to do the same thing I did on the previous slide. What does that milli mean? The milli, that little m right there, means 10 to the minus 3. So I have them on opposite sides of the equal sign. 1 milliliter equals 1,000th of a liter. Nano means 10 to the minus 9, or 1 trillionth. So 1 nanoliter equals 1 trillionth of a liter. So now I'm going to use both equalities as conversion factors, and I'll have two sets of parentheses here, so two conversion factors. My starting value is here, 9.6 mils, and my first conversion factor converts between milliliters and liters, and that will cancel out the milliliters. My second conversion factor converts between liters and nanoliters, so then that will cancel out the liters. And then it's a matter of, again, filling in those conversion factors, those numbers, from the equalities that we created. So for the first one, 10 to the minus third liters on the top, 1 milliliters on the bottom. So it's almost easier to see, even in fraction form, that the milli is opposite the 10 to the minus 3. And then in the second one, the nano, the n, is opposite the 10 to the minus 9th. So then we can cancel out some liters, we can cancel out some milliliters. Sorry, I didn't show that with a line, but that gives me a value of 9.6 times 10 to the positive 6 nanoliters. You should be able to do that in your head now that we've had some practice. Looking at exponents here, we're dividing, so I'm going to subtract the exponent. Minus 3 minus negative 9 equals 6. So 10 to the 6 is the exponential. This slide is just in here to give you kind of a reference sheet for some of the stranger unit conversions, the non-metric unit conversions, and the ones with arrows are ones that we might see every once in a while. And then another really useful thing to have in the front of your mind is the relationship between liters and cubic length units, like centimeters cubed or meters cubed. If we look at this box right here in the middle, this is showing a volume of 1 liter. If that were a 1 liter container, a cube, each length would be 10 centimeters. And so if we then take one of those small boxes in there that's 1 centimeter on each side, that is equivalent to 1 milliliter. So basic thing that I would keep in the middle of in the front of your mind is just that 1 centimeter cubed equals 1 milliliter. That'll help you on some of your conversion problems in class on Friday, and there's a few other ones here that you can reference as well. Temperature conversions are a little different. They're not metric based, and there's some formulas here that allow you to convert between Celsius and Fahrenheit, and then converting between Celsius and Kelvin is actually even easier. If you have a Celsius temperature, like the freezing point of water is 0 degrees Celsius, add 273.15 and that's your temperature in Kelvin. So the freezing point of water in Kelvin is 273.15. So there's a few here to work on, and we will continue working on this in class on Friday. Thanks, bye.